one, right? But today we are going to talk about MagneRide suspension. It's been around for quite a while, 2002, and it's an adaptive suspension system. Basically, they take the shock absorber and they make it adaptive to the roads and the condition and how the driver wants to drive the vehicle. And it was developed by Delphi Automotive. And then it was used in the 2002.5 Cadillac. But since then they've used it on, there's a wide variety of vehicles that use this. Around the auto industry collapse, if you will call it there, in 2008, 2009, so forth, GM sold the Delphi chassis group to Beijing West Industries, BWI, who owns it now. And by the way, they have a manufacturing plant that they just opened up a year ago in Indiana. I think it's in Greenfield, Indiana. So they're manufacturing these things, and they've got headquarters and like technical centers across the U.S., but now they're actually manufacturing in the U.S., which is good to hear. So yeah, a lot of vehicles use MagneRide. Not everyone uses the name MagneRide. If we look, this is a list of the variety of vehicles or manufacturers you might find it on. Like our Camaros that have a good package, a good suspension package will have it. They've had it available for the Corvette since the C5. I haven't looked to see if the C8 has it, but I assume it does. The many Cadillac models. I mean, if you look at the list, go to Wikipedia, that's where I got all this information from, Wikipedia. But there is a long list of Cadillac vehicles that have it, and we have it on a variety of our vehicles out here. Most of them are on our Cadillacs. So the Mustangs, Ford started using it, and they use it on the Mustang, the EcoBoost, the Ford, the GT, Mustang GT, the Bullitt, Shelby, the GT 500. So that basically they're sports cars. Now, actually, the F-150 has something that I don't think it's MagneRide, but they actually have a dampening system as well. Acura MDX, which is kind of interesting, it had it from I think 2008 to 2013. And they also had it on their ZDX, and they have it on the new NSX. So they use it as a tuned suspension for the NSX. The Audi uses it on a few vehicles, Land Rover, Ferrari, Lamborghini. So you can kind of get the hint. Other than, and I didn't mention, here's the trucks, the Denali and the Yukon and the Suburban, they have it as well. But most of these vehicles you're going to see are performance vehicles, and that's why they like the systems, because it's an adaptive, tunable suspension. So how does it work? The heart of it is in this shock assembly right here. And I've got one right here that I've taken out. This is out of our Cadillac. And so it's a simple system. When you look at it, you're like, oh, it's just a shock absorber. But they've got a connection at the top here. It's just a simple little 2-wire connection. And what it's doing is it receives current, goes down into the piston assembly that's in there. And that piston assembly has 2 windings, magnetic field, 2 coils basically, electromagnetic coils. And that's actually, the 2-coil thing is an advancement. That's something that they've recently done. In the past, they've used 2 coils, and I'm getting dings. Let me make sure my audio is working. Okay, Ashley, she's laughing at me. But so the 2 coils that are in there is something that they've advanced to on these the 3rd generation MagneRide. And the reason why they added the 2 coils is because they found on the earlier versions, when you energize the coil, you created that electromagnetic field, and that actually slows down current flow to it. It kind of creates a counter electromotive force, and also when you turn it off, that collapse of that magnetic field induces current. So they actually wire the 2 coils and kind of to oppose each other, and that eliminates that. So it allows this to work quicker. They say this works within 1 millisecond. So 1,000 times per second, this can make an adjustment, which is pretty impressive. Oop, didn't mean to click that. So yeah, when we look at the inside of the system here, that's where that coil is, and this is that piston. Now the body of the shock moves up and down around that piston. And the way a conventional shock works is we've got holes that are pretty much drilled between these 2 chambers. This is one chamber, and this is another chamber, and we have these holes that are drilled through a piston. And there are different shock designs where they try to make it so that it will change based off of how quick a shock moves. It'll change how quick fluid can flow through there mechanically. But what this does is it uses a special fluid in here. It's called ferrofluid, or it's actually magnetic rheological fluid, but some people call it ferrofluid. Ferro from ferrous, as in like iron. attracted to magnetic fields and so forth. And that's really what's happening. There's particles of iron or a ferrous type material in this fluid, and when it's trying to pass through this coil assembly with the orifices, the holes that they have, if they change the magnetic field that's inside this piston, they can align. That's what these little pictures here are showing. These are not aligned, so there's no electromagnetic field present. And then when they energize it and they create the electromagnetic field, it lines up these iron particles or ferrous particles in the fluid, and it makes it harder for it to travel through the holes in the piston. So they make the fluid thicker, in a sense, by doing that. And I don't have a very good demo of that, but what I did do is I took, and we'll see if this can show up. Let me spin this one monitor around. I meant to do that earlier. It's my, the one where I can see the camera over the camera and see what I'm doing. But this will help me maybe make sure that I'm in focus and I'm showing what I want to show. But okay, here I am. So this is a little mason jar. Probably have seen those before. They're pretty cool. Yeah, we all have mason jars at home. You can jar tomatoes and stuff like that. But this isn't about mason jars. This is about MagneRide, or magnetic dampening suspension. What I've taken is some transmission fluid and I've put iron shavings in it from the brake lathe. And you could see if I twist it, the metal flows. It's a little slow, but it flows. So imagine if it's flowing from one chamber to the other, one part of the dampener to the other. But now all of a sudden, boom, I place a magnetic field there. You can see it doesn't want to flow, does it? So take the magnetic field away and it flows down. Gravity pulls it down. Place that magnetic field in there, I can suspend it. So I can make the fluid thicker. That's my crude way of explaining what they're doing, but you could probably imagine it even without this silly little display of what they're doing. They've got, now of course, those are brake shavings from the brake lathe, so they're big. And who knows really what they're putting in that rheological fluid that they've got, magnetorheological fluid. But whatever it is, it's changing the viscosity of the fluid when it's passing through this magnetic field. It's not changing it up here, it's not changing it down here, but as that fluid tries to find its way through this little piston, depending on how strong this magnetic field is, it's going to change how thick and how quick the fluid can flow through it. So that's the kind of the down and dirty of how it works. And it works fairly simple. You know, when you think of the concept at least. But this is a diagram that comes from Acura. The MDX or the NSX, they pretty much use the same document in both. But what it's explaining is that your conventional dampener is this single black line that's following here. And that's on compression, like when you hit a bump and that wheel's trying to tuck up into the suspension. And then this one right here is the rebound, what a traditional shock would do during rebound. Whereas everything in the gray, and this is showing like how much dampening it could do based off of how fast the shock is moving. But everything in the gray is what the magnetic suspensions can do. I'll just call it MagneRide, the MagneRide. They like to call it, I can't remember what they call it, active dampening system. But what they're basically doing here is anything that's in these gray boxes, that's controlling the rate at which you can go through and adjust the adaptability or the adjustability of the suspension. So they can let the suspension jounce up quickly or slower. They can make it rebound quicker or slower. And think about the reason why we're doing this and the reason why we have it on sport cars, you know, like the Acura NSX or the Yukon. No, actually that's not a sports car, but they're doing it for ride quality on that. They're doing it because they want to keep the vehicles, when you're going into curves and so forth, they don't want to see the vehicle rolling over. They, literally rolling over, but actually even pitching or tilting. They want to see that car stay level. And because obviously if you fly into a corner, momentum is going to carry you straight and it's going to try to take the vehicle and cause it to lean. And that's going to distort the tire contact patch that you have between the tires and the ground. If you can keep the vehicle level, you're going to have a better chance of maintaining traction. It's just like if you keep a level body while you're running, if you're a football player, you don't see these guys leaning like crazy because they'll lose traction, they'll slip out. So they try to keep their upper body level when they're running side to side. Anyway, this system here, it can look at what you're doing when you're steering. it can look at your accelerometers, and you're going to see here in a second, it also has these position sensors that they can measure the position of the suspension at each wheel. And then they can immediately adapt the suspension to kind of make it the best ride characteristic as possible. This is a typical layout. You know, we've got our shocks, our strut assemblies for all four wheels. This is on the 2010 Acura MDX. They do have the suspension sensor height sensors, basically. I said sensor too many times, but they got the height sensors located at each wheel. And the one thing that Acura and I believe Ford even does it, but I might have forgotten that, is they use these accelerometers. They got these vertical accelerometers. They got 3 of them, 2 in the front, 1 in the rear. So that's measuring, and actually they're G sensors. I think they measure all 3 axis. I really can't verify that, even if I could, because it's a communication signal. It's not like a varying voltage signal that gets sent out. It's a smart sensor that sends out information that the modules use. But either way, they call them vertical acceleration sensors because theoretically they're measuring how much the vehicle is changing in height. And you can see here's one in the front. We've got our 2 out in the back. And then you can see they've got the module back there and our suspension. So it's a pretty advanced system. You see it on the Lamborghinis and Ferraris and the Acura NSX, but you also see them on most Cadillacs and even your Yukons and your, the Denali models and so forth. This is a wiring schematic for the Mustang. You can see it's just a simple 2-wire coil that goes to each one of these. And then actually I take it back, the Mustangs, the Ford does not use the vertical accelerometers because on the wiring schematic you can see they just basically have, here's our 2-wire suspension, the dampening systems, the shocks, and then we've got 4 suspension position sensors. They're going to measure the position of the wheels. So yeah, 3 wire sensors, real simple. They are just like throttle position sensors. As the suspension moves up and down, they move a wiper, and that changes the voltage that the computer can see. This is the Cadillac CTS-V wiring, and that's what we're looking at. That's the shock that I have available. These are the dampeners down here. We've got 4 of them. These, by the way, are very low resistance, and I'll show you that in a second. They're only about an ohm by the time you're done measuring it. So if you were to think, if you used your Ohm's law that you learned in school, if you got 12 volts and you only have 1 ohm, you could pass 12 amps through it. So that's quite a bit of current. Now, I do see, looking at the scopes, that it can pass 12 amps, or 5 amps about, so they duty cycle it. they don't really turn the duty cycle on 100%. If they did, you'd be passing 12 amps, and that might be too much for that coil and burn it up. But so even if knowing that, since they only pass about 5 amps through that, I don't know if it's the safest thing to sit there and hook a jumper pack to it to see if it works. Not unless you're willing to I think these things are on a timing, which I did not realize. But okay, and then these are our position sensors up here, and you can see they're this simple 3-wire. We've got power going to it, a signal wire. That's this one here. That's that little arrow right there on all 4 of those. That little arrow basically signifies that they're monitoring the voltage right there. And then we got the sensor ground right there. And all 3, so we got it for all 4 wheels. Now this is a video that I did. I drove the vehicle. I have a friend that has a Cadillac, and he so graciously let me borrow it. And what I have down here, this is amperage. I put 4 amp clamps on the wires that lead to the individual shocks, and you can see me driving it. And then every once in a while you'll see the voltage kick up or kick down. That's me switching between sport mode and touring mode, and I put that on there. You could even see, there's a section here where I drive over. You can see me swerving. Look how much the dampening occurs, how much amperage they pump through that. And I'll tell you, that vehicle does stay level while that's happening. And in a second, you'll also see me drive. I steer the vehicle off the road a little bit. Don't tell my buddy that I did that because he might be a little mad. I only took one. I didn't go off-roading. Didn't kick it in 4 low or anything like that. I basically let 2 wheels go off to the shoulder a little bit. Took a couple cyclists out. Oops, sorry about that. And you can see the suspension, the amperage change at those wheels, and you can see right where I pulled back onto the pavement. And up here is scan data. This is the duty cycle, and this is the position of each 4 wheels. So this would be our front left, our right front, right rear, and left rear, just like the 4 wheels of a vehicle. What's interesting to note is that the rear suspension isn't nearly as active as the front, which kind of makes sense. But you also think we've got a bunch of devices on our vehicles that help kind of control sway and so forth, like a sway bar links and the sway bars themselves. But this is an integral part to that too. By adding this, if you go to swerve, not only does our sway bar links and our sway bar assemblies try to keep the vehicle level and even, but this thing can now stiffen up the shock on that outer wheel. And when you swerve the other way, it could stiffen up the shock on the other wheel. Actually, if you notice, it does both anyway. But it's pretty neat to see that this is a feature that can control and help not only keep the vehicle stable, but also improve performance in steering and handling. And it does so super quick. Now I had to kind of match the video of the snapshot. That's when I pushed the button, by the way, right there, and I switched it to sport mode. Every time you push the button while you're moving to sport mode, it amps out, it just pumps a lot of amperage to those coils. Don't really know why, but it does. You can see how quick it reacts. Second you turn it, it looks at the steering angle sensor, it looks at the accelerometers in the vehicle, and looks at the suspension position sensors, and it makes an adjustment right off the bat. So this thing's happening all day, every day, while you're driving your vehicle. Something to think about. Very active. This is during the touring mode and two wheels are off-road. It still does a lot of reaction, but when you're in the touring mode, you can see that they're fairly flatlined. There's not much current flow going through it. They let the shocks kind of work in their comfort mode, if you will. And then if you switch to sport mode, there's going to be more reactiveness to it, and the vehicle is going to be a little rougher of a ride, but they want the suspension to be stiffer. And that's kind of neat when you think about it, because the suspension is variable. Those orifices can stay the same size, but as I change current flow through it, I can make it work like a completely different shock. So, fun stuff, huh? All right, well, I'm going to switch over to the vehicle that we have real quick. And we're going to look at a few things on the vehicle. I went ahead and put you take a look here, a little multimeter, DVOM. You could read that okay, I assume. I'm just going to go ahead and show you the resistance of it. If I touch my leads together, you can see I've got 3/10, 2/10. Wow, that's a lot of resistance for, okay, let me rub them together, that'll help. It's all over the place, but about 2 or 3/10 of an ohm. If I want, I can do a delta and clear that out, but I'm just going to assume that 2/10 of an ohm, I can subtract whatever I read here from 2/10 of an ohm. So now you can see that I'm across the coil. I'm only measuring 1.1 ohms. So we're really just a little less than an ohm. And the reason why I mention this is because the vehicles, you'll see that some of these people that have this system, when it goes bad, they want to just replace it with a normal shock and defeat the system. And you can do that. They make these delete kits, and I'll show you a link to that later. But some people will want to just put resistors across that connector, and that might work, but you're going to have, because this system has to pass a decent amount of current, you're going to probably have to have a low resistance coil assembly in there. And that's not, so you probably have to get those ceramic resistors. I think you might even have to get a few of them and parallel them together. I don't know. If you've ever done that, let me know. I know the system that you can buy online, it costs about $450. So, but other than that, I mean, you can defeat these systems, but you're either going to have to experiment or you're going to have to go through and buy a kit. Now the thing is too, is if you decide to defeat a system, you got to ask yourself why you're doing it. I mean, I've got prices. I show you some common street prices of these different parts and pieces, and they're expensive. But you know, what are you buying? You got a Cadillac, you got a Corvette, you got a Lamborghini or something like that. To spend a few $100s per shock to keep the suspension riding the way it's supposed to, I don't know if that's really that bad of a deal. Okay, I'm going to raise this car up and we're going to look underneath it real quick because we can see how this thing is configured underneath there. We'll go over to my little setup here. Wonder if anybody's commented on any of this stuff. We might be able to take a peek. I'm doing this solo, as you guys can imagine. So let's click on me, that handsome man right there. Whoa, I don't want to hear you. Hey, my daughter's in there. It says, "Go Daddy, thanks." And manual raise is in there. Nice. And okay, let's see if who's live. It says I'm live. Sorry about showing you the wall. I guess I could have panned down a little bit. This is my monitor the system, make sure, see if anybody's got any questions or comments. Nothing so far, and that's good news, because usually the comments are, "Hey, your audio's not working, I can't hear a thing you're saying." But we're gonna raise this Cadillac up. This is the school's Cadillac. I returned my buddy's. I don't think he'd appreciate me taking his apart, so sorry I didn't. I wanted to show you that on the ground, so now you have to wait for it to raise up in the air, but it's all right. You know, this is kind of therapeutic, right? Sit there and watch a car go up and down. I think so, especially a nice car like a Cadillac, CTSV. Might have to get me one of these. If you didn't know, these are supercharged, and they're super fast, and they're super fun. This is the underneath, if you were wondering. Now, of course, you could figure that out because you're watching me raise it and then walk underneath it, but kind of travel on our way to the back. And what I wanted to show you is the sensors, the position sensors. They are, this one's pretty, oh, hold on. I'm trying to hold two things at once. Let me, I got a light in my hand, a gimbal, and just, it's a mess. I'm gonna zoom back out. I had this thing zoomed in. Okay. Right, this little jobber-do right here, you can see I got my finger on the wires up there. That is the level system there. That's going to be monitoring to see if what the suspension height is at. This linkage that we have right there, put my finger on it, that is the device that is going to be hooked up to the control arm. And then the bracket right here is held to the frame of the vehicle. And then as you go up and down, this moves, and that wiper basically changes the position of a little wiper arm in there, and that changes the voltage to the computer. I got one on both sides. This is the one I took the shock off of, so it's that's my lift. It's missing the shock, but you might be able to see the suspension level right there. Brink. Okay. And then going to the front. The front they put it up higher, way up there. You probably want to take the wheel off to get to it. And let's see if I can put my light up there. Way up there. Think that light will stay? Yeah, sure. I'll zoom in. I'm going in. Right there. Focus. Not the best focus, but it's there. Okay, so that's that. That's what we have underneath. Pretty simple and straightforward. Now I'm back over here. So some of the things that we can check for, obviously we can check that linkage to see if it's broken. Apparently the systems can't check that. I think some the newer vehicles can, but I actually stated that in this vehicle it cannot do that. So if the linkage was off, it would probably believe it and it wouldn't set a code for it. So check for that. And check for leakage. There's actually a bulletin out that says that if you have leakage on just a small part, like a third of this, there's nothing wrong with it. That's just normal. That magnetic fluid attracts dust, which it probably does. And then they stated that they showed pictures. If it's got leakage more than a third of it, then you need to replace it. And they only want you to replace one side at a time. They don't want you to replace the whole thing. So that's good to know. Things that you can check with the scan tool. DTC is pretty easy. If you have an open circuit, shorted circuit, and so forth. Energize your shocks. You can do that with the scan tool. You can activate them, turn them on, and turn them off. So if you're just doing pinpoint checks at the shock, you can like hook your voltmeter up, turn it on, see if you're getting power to it, maybe an amp clamp to see if you got current flowing through it. That would be a way to check it. So that's, really energizing is going to give you the ability to check current flow and the voltage, because you know it'll be commanded while it's being energized. These are some of the DTCs that we'll actually have with the Cadillac. You can see there's a variety, and if you look some of this chart, at the top we say it's short to ground, open high resistance, and short to voltage. And then at the far end it says signal performance. You can see there's nothing listed for that because they really can't check the signal performance for the actual coils that we have in the shocks. But when we have short circuits and so forth, and you can tell between the different terminals, the codes are going to be the same in some instances. But in this situation here, we're basically looking at, we've got this wiring, and they provide power and they provide a ground. And you can see they both show switches. So with the fact that these both have switches on them, that it's probably going to control the current, or as it's turning it on, it's providing a ground. So when they're turning it on, if they turn it on first, and before they provide a ground, they should see 12 volts there, because voltage builds up to the point of the open. We all know that. And then if they provide a ground, or they can check for voltage on this side too. They don't show the little arrows like the signal thing did, but in order to set those DTCs, they are going to have to monitor the voltage. Let me back up. I don't know why I did that. They are going to have to monitor the voltage on these circuits. So depending on how these fail, they're going to set those codes that we see right here. Same thing kind of goes along with the position sensors. They've got short to ground, open high resistance, short to voltage. And then this shows it does have a signal performance. So maybe on this Cadillac, if it wasn't moving and they're expecting it to move, they saw the other wheels moving, maybe it would set a performance code. But they're doing the same thing. When we look at the wiring schematics, since we have the ability of measuring the voltage here, they know that it should be between like 0.5 and 4.5. It's fed 5 volts, and then of course a ground, 5 volts here, ground there. So the normal range would be between 0.5 and 4.5. So if this ever read 5, it knows there's a problem. If it ever read 0, it knows there's a problem. So what is the problem? They don't know, but they can break it down into these. Basically, either it's going to be a short to ground, open high resistance, or short to voltage based off of the unexpected reading that they're going to get. And these codes right here are just going to direct you, if you follow the diagnostics, they'll direct you in a path to actually check that. Here is actually some of the costs that we've got involved. And if you take a look, this is on the Acura MDX. They're not cheap. The front units are almost $600, and then the rear's $361. So I kind of see why somebody with the Acura MDX might want to just try to figure out to squeeze a generic one in there and defeat the system. This is on the Cadillac. The RPO code is the F55, and you can see it's not as bad. 250 for the rears, 370 or so for the front. Not cheap though. And then this is the truck. If you've got these are all the different truck models that it comes with here. If you look, the Cadillac Escalade, Silverado, Suburban, Tahoe, Sierra, Yukon, and the year range, and they're about $310 for those. Just in this example, their RPO package is a Z95. So this is the website. It's shocksims.com, and if you click buy now, you can see what the prices are. They sell you a system that can do half the fronts, or that they can do the whole system. It's about, I think it was $260 for the front only, and almost $500 for the whole system. And what they do is they give you a unit to plug in place of the shocks, and they also give you a unit to plug in place of the position sensors. And then it feeds the system information, which it believes, and it keeps the check engine light off. Or not the check engine, but the stability light off. Basically, if you've got a stability light, from what I understand, I haven't verified this, but it will limit your top end speed, and it'll also maybe prevent your vehicle from operating in the stability mode like it should. So anyway, that was just a brief rundown of how the MagneRide system works. If you have any questions on anything, feel free to post up and give me a question. I'll answer what I can. If you want me to do some kind of a measurement or experiment, let me know. I can do it, possibly. I don't know, I could try. And if you have any other ideas or topics for me to cover, this is the Cool Tech at the Tech series. We've got tons of stuff out here Not everything I'm an expert on, but we got a lot of good faculty out here that I could bounce ideas off of, and maybe I can get them to help me out. That'd be great. Otherwise, I'll sign out and thank you for watching this, and I'll see you next Friday. I think next Friday we're supposed to do direct injection. Yeah, that sounds like fun.